matter movement in cloud environments. And let's welcome Priyank.
Thank you so much. All right, welcome to this talk. We're going to discuss some cutting-edge post-exploitation techniques. During post-exploitation, how many of you have ever felt like, man, there has to be some better way rather than dumping LSASS or credential dumping, Every day, right? Yeah. So we're going to discuss a few techniques about how not to touch that and maybe stay undetectable for as long as possible. But before that, I am Priyank. I'm a senior red teamer at Microsoft. I'm fairly active in the responsible disclosure space, work very closely with MSRC and stuff like that. I have a bunch of research interests, and I'm not so senior blue teamer at home because I have 2 toddlers now. So they always defeat all the restrictions you put on their mobility. So here's the agenda. We're going to discuss the post-exploitation landscape, how it looks like currently. We're going to discuss what the protected and aka noisy objects are. And then we're going to do a deep dive into the WebView-based applications, which typically are M365 apps. They communicate with Entra ID. We're going to see, if you can dump them, look at the file storage, look at particular interesting stuff there, see if we can laterally move. And then we will discuss some detections or defenses which could be devised based on the techniques we discuss. So the scope of this talk is I assume you have some kind of initial access in the environment, and we want to stay undetectable for as long as possible, right? So here's the biggest misconception. A red team operation is trying to emulate a threat actor, right? But threat actors don't want to really go after credentials or stuff, right? They are just a means to an end. The final objectives is usually persistence, further recon, or data exfiltration, like emails, tokens, persisting in cloud world, like storage accounts or key vaults or stuff like that, and see where they can pivot and go deeper into the network, right? They don't care about someone's password or something, right? They want to go after someone's email. That's the thing, right? So let me do a quick refresher on OAuth. So OAuth is authorization framework, allowing third-party applications to authenticate as the resource user. And in exchange for that flow, so for example, if it's a client-based flow, client credential-based flow, you get several type of tokens. So one of them is the good one is the access token, and then refresh token. They basically give you short-lived tokens to authenticate on behalf of the user. They are typically short-lived, an hour in Microsoft environment. Refresh tokens are longer-lived. And then there are also more longer-lived tokens like PRT, which may be of interest as well. We'll discuss that. So here's the client application, which bears the token to the resource server. So for example, in this case is a Microsoft Graph, which exposes the API as a scope to Entra ID. And that's how they actually authenticate as a user. It all assumes that the resource user has already pre-consented. The funny thing is that several first-party applications are already pre-consented in your environment. So for example, think OneDrive or Outlook or stuff like that. So the reason you just sign in once and then everything else is signed in on your behalf is usually because it's all pre-consented for first-party applications. So we're going to exploit this fact. So in a normal scenario, you want to do credential dumping. So local security authority subsystem service, LSASS, as we all know, the first thing we red teamers do is basically go in, dump the wregist, get the stuff out of credentials. But this is becoming much and much easier to detect. Every EDR, any EDR worth their salt is going to detect any of the techniques. And these are also evolving day by day, right? So you could do process herping or an actor using a write, map, modify, execute, close workflow. That will be detected, right? Native API, DLLs, silent process exit. A lot of stuff is already baked in a post-exploitation tool. They will all be detected. For cloud environments, you want to go after authentication tokens, which means you're interacting with a browser. So the easiest way is to go after the cookies file, which is typically present in, so any browser which your organization uses for SSO, typically Edge, Chrome, or any Chromium-based browser, maybe even Firefox, actually. Those are still DPAPI encrypted, the cookies file. So the way it is encrypted is like the key is still stored within that file system, within that path. It's just that there will be a DPAPI decrypt call, and any EDR can detect that. It's easy. And of course, if you're lucky, you'll find stuff in plain text files or stuff like that, right? So the conclusion is like you leave these protected objects alone and focus on something which may have really low detection rate. So enter M365 apps. When you have like a out-of-the-box Windows OS, you're going to see a bunch of applications pre-installed, like Outlook, Teams, Copilot, OneDrive, stuff like that. And these are all required in an Entra ID environment, right? Once you sign in, you can sign into all the apps. So the way this works is like the OS contacts a domain controller, it gets back a PRT back, and then it issues tokens for every other app which you're trying to use, right? So the way this is like a web views is, think of it as like Electron apps, and then they are just in between native apps and browser-based websites basically, or progressive web apps. So you don't have the whole power of native APIs on the OS, but also you're just not like a dumb website which is just operating through a browser. So you have a little bit more power. So WebView can actually interact with a lot of stuff, like apart from just the file system, right? And it has like a little bit more reach. So here our idea is to attack target those apps, and then fetch the ESTS token or primary refresh token or something longer lived for that particular user, and then see where can we go with that. Also, this is applicable to most other browsers, because turns out pretty much everything is based on Chromium these days. So when we started researching this problem, we ran into some issues. So they're like, when an application is WebView-based, it spawns multiple sub-processes. It's typically 7 or more, maybe 7 to 10 per process. So a bunch of it is like just renderer process, GPU process, utility processes. And then, so for example, in this case, this is for Microsoft Teams. You can see there's like a bunch of services. So we started digging into like which could actually give us access to applications which might not be intended. So on a typical Win11 machine, if you just do like a get process in PowerShell and just filter it by WebView, you'll see something like in the order of 30s actually. This is actually less. And then if you dive into the command line arguments about what that process is, we discovered like there's some interesting stuff. So this is the utility process which was one of them in the sub-process list. The subtype is very interesting. This is basically from Chromium project. It's a storage.mojom.network service. And you can see the parent process which spawned this was Teams. Now it turns out that, and this is the target users directory where everything else is running from. So you're going to see very typical path like within local app data, and then the binary name, and then EB WebView. So you're going to see that default profile within. It's basically as if you're running a Chromium profile for each application. So it's nothing but just a collection of runtime libraries providing a platform-agnostic way of dealing with IPC. So we don't need to care about that. The advantage for us is like if you try to mess with any of these processes, it's handled by the browsing, the rendering engine itself, and it's going to get respawned. So even if it gets crashed, you're trying to mem dump or do something crazy with it, it's really advantageous for us because nobody's monitoring for that, and even if it gets crashed, it's going to be back up very fast. because this is actually required for the functioning of the application. So moving on, if we try to filter with the utility type, we bring back the count to a much easier number. So right now it's 5 for each particular application. So for example, right now I'm just seeing MS Edge. You see there's Adobe Creative Cloud UI, MS Edge WebView, and you see, yeah, I didn't see the parent process, but it's probably for one of these M365 apps. So the conclusion is like the storage service basically has access to the local access tokens, which are valid for at least 1 hour. And the refresh token is also valid for at least 24 hours if you get to that. However, it's just that it's a little difficult to identify refresh tokens because they are like really encrypted, but they do follow a particular pattern. Access tokens are unencrypted. You could just, it's just a JWT. You could just base64 decode and you're good to go. You'll realize what scope it's for, what's the audience it's for, stuff like that. What's the expiry date? So, and then you target network service for cookies. So, as you know, browser-based applications rely on cookies for authentication. So, those cookies, for example, the longer-lived ESTS tokens live as cookies as well. So, either one of them, and you're like pretty good for that particular user. So, the approach we had was to create like process dump using, there are different dump types you could do a process dump. So, for the particular environment we were targeting, it was like mini dump write was not detected. So always try this, depending on the environment. It may or may not. But basically, this is the mini dump type, and then you just run it. I think it's a part of the K32 DLL. If it is detected, you'll see something like this. But I'm very confident everyone should try this. The only noisy thing is like you have to do an add type, but I think on a typical developer machine, it's very normal behavior, like you're doing add type and you're just importing the debug help.dll, and then just exporting that function for the mini dump write, right? And then so we just run that on pretty much everything WebView specific, and we're going to do all the post processing on the device itself, rather than accelerating out. So there are other ways, as I said. So you could do like procdemp, which is again sysadmin tool, but it may or may not have that. In my opinion, I didn't see any of the tokens there. And also, despite its name, mini dump might not actually be a really small dump. It could be larger than a full process dump. So don't be fooled by that name actually. So once you have that dump, you could basically do a regex on the device itself. So in this case, I'm just doing a regex on JWT, this is base64 encoded for any JOT, as you might all be aware. It's basically header.body.signature. You don't care about signature. And then you're going to, because this is unencrypted, you just base64 decode. You could see the audience. So IC3 is the communication framework for Teams, which handles audio, video, and chat as well. And then you could see what kind of audience, other target audience you might want to scan the dump for. So typically, outlook.office.com is for mail, or api.office.net for the previous legacy API for Office mails, or one of the most powerful ones is Graph. If you get that, then you get access to pretty much a lot of other information for that user. So once we have a hit for all these tokens, we're just going to get a hit and just exfiltrate that to our red team infrastructure. The only drawback is that the tokens are only valid for 1 hour, so you need to have automation set up to do whatever you intend to do. So if you wanted to get fetch mails, make sure you get that correct token for that particular audience. Make sure you just hit the Graph API and just dump whatever you want, or search for subject name or something like that. Or we could go for refresh tokens, but they cannot be really mapped easily. So this is like, it's basically, this is like simple regex, but this will give you a lot of noise, so we'll have to try over and over again. But once you have that, I'll show you how you can use that to switch between other applications. So for that particular target, we went from dumping almost 7 processes to almost 2, which made sure that we are running for less than, earlier we were running for more than 750 seconds. We went down 84% by just targeting specific utility type processes for WebView, and then looking for tokens, because that has like a really high success rate. So once we get that, as I said, the claims are unencrypted but signed. And once you have valid for a specific service, graph is really powerful. You always want a graph. But if you get a refresh token, there are like some undocumented the foci flag, which is a family of client IDs within the auth code grant flow, which can be used. Refresh tokens could be exchanged for access tokens for other applications. So for example, you get a access token for Teams, you can interact with SharePoint, you can interact with Outlook. How that works is like basically because Microsoft has mobile clients for all of these applications, and those are like unauthenticated first-party applications. So, and they all need to talk to each other, and that's the reason this thing exists. Like there's like this whole trust. And the second reason is like the applications themselves. So if you load up Teams, it's pretty much like a workspace of all the applications. When you hit upload, it's actually going to SharePoint. Where does the Teams get token for, right? So that's how it works under the hood. But as a red teamer, as a penetration tester, you can exploit this for lateral movement. So now so we are still within the same user. We're going to see how to expand that. So this is like a very simple way. This has been fairly documented research, but folks are not aware. I'm just doing that for completeness sake. So this is just PowerShell. You open up as a public client application for Azure PowerShell, and you request initiate a token for graph.microsoft.com. The user is going to see something like this. Are you trying to sign in to this particular application or something? Once you do, and once you do, you get the access token, and you can inspect the scope, which is pretty much directory.access as users. It's pretty much like a user impersonation token, right? So once you have that, you'll also get the refresh token within this chart. And then, so the issue here is like, once you have that, you could get an access token for a different client and scope as well. So remember, we got that for Azure PowerShell, but using that refresh token, if we request a scope for service.powerapps.com, which is basically the API for interacting with Power Apps service, Power Platform, you see that is very successful, because now you could interact with the Power API using that impersonation token. So how you see we kind of jumped from one app to other app. And so that's kind of breaking the 2 rules of OAuth, right? It has to be scoped to one particular client, and it has to be scoped for one particular application. So you kind of broke that cardinal rule there. And this is another example is like you have this, I initiated as a Teams client. This is a public client ID for Teams. You see that the refresh token could now be exchanged for a access token for the scope for powerapps.com, right? So that's pretty crazy. You could use certain red team tools for doing that, like row tools or stuff like that, but these have like a very high detection rate, so that's the reason we are going line by line. You could actually do that on the environment, and I'm pretty sure you will not get detected. So this particular research is publicly documented for more than a couple of years now, but feel free to go dig in more. It's very interesting there. Yeah, what we found was like it gets more interesting. You could actually jump from consumer apps to enterprise apps in Azure So for example, we went from Teams to getting a scope for Azure Key Vault. That's pretty crazy, right? Because now you went into all the enterprise resources hosted in Azure, and that's what the real attacker is there for, right? This one, yeah, this is in Key Vault. You could go to storage accounts. You could try to get into the management plane for Azure. So I think the scope is like management.azure.com. So you have to try all these combinations. I'm pretty sure you'll get one of these. Every environment is different, so what works here might not work in yours. So always do that. One of the funniest pivots which I came across was using MS Bing search on mobile. Now this application is like pretty much available to all. If you do that on your enterprise managed device, you could interact with Power Apps REST API as the same user. Now, how crazy is that? Because your mobile device might be compromised in some way, and then that malware will be interacting with all other enterprise apps. So it's really bad. So yeah, some first-party apps are trusted to trust different applications. So every environment is different, and that's how Entra ID is set up. So always audit for that. Sorry. So moving on, we paused a lot of memory. Let's look at the file storage now. So this is the, as I said, this is the location where all applications function from. So local app data packages, as you can see. So it also contains the cookies and the key to decrypt the file, which I already mentioned. So you could easily do that, but you don't want to do that because it's DP-API encrypted, right? So so looking at the, there are like some synchronous files which are also created when you use these applications. They're called LevelDB. It's basically like a fast key value storage program created by Google. It's designed for speed, and that's about it. But it offers like a really high performance than SQLite. That's the reason they're using. So you're going to see a lot of synchronous calls as you are using these applications. And then some of these, they are like, they're spontaneous. They may or may not, exist at certain particular time. But most likely than not, they are going to contain secrets. So if you're just going to like grep for it or just open it in Notepad or stuff like that, you could just do like a offline dumper. Just grab all these files, take it to your infrastructure, dump it. You'll pretty much find a lot of stuff in there. So those are like exploring the file system for WebView apps. So let's do like a primary refresh token primer. Once you have these tokens, there's like other ways of attacking the target system, which you are already on. So a primary refresh token enables users to have like longer, really long-lived single sign-on tokens on the device, right? Typically 14 days on a rolling window basis. The keys are stored within the trusted platform module of the device, so it's like useless trying to attack that because you can't decrypt that unless you're attacking the TPM. And then all major browser windows now support SSO, and the reason they could SSO is because of the PRT. So earlier it was only Edge, but Chrome used to do it via an extension, and then some folks have actually reverse engineered that, which is very good to know like how it actually functions. So this is still present in Chrome. It's called Microsoft Single Sign-On. The way it works is like the page in the browser interacts with the Chrome extension using JavaScript, obviously. But there's this binary, browser.code.exe, and it uses native messaging to pass messages between them. And then the way it interacts with the token provider.dll is via COM. So the folks reverse engineer it. There are like basically two class IDs for COM. Once you know that, you could you will get that. You will get the PRT tokens. And the PRT tokens are set in these two particular HTTP headers, which I'll show how to exchange that. Once you are doing a OAuth call to the authentication endpoint, you're going to pass these two. So the way you could bypass this, you see, you just interacting with the browser core, you could directly bypass this whole thing and use your program to interact with browser core, which will do the work on your behalf. Or you could use the COM object. You could instantiate that yourself and then interact with the DLL yourself. So this is the first time. This is the first way where this is just simple Python script where you are interacting with browser core. The method for within that which this application exposes is called getCookies, and it also expects the sender name, which is login.microsoftonline.com. That's true for enterprise apps. If it's for MSA, like live IDs, which is like, I think it's login.live.com. So those are the two things. And then for authentication for this particular URI. So you're going to get back these two tokens. Or you can directly interact with the COM object, as I said. So these are the class IDs. These two are the class IDs. You can get that, I think. So this is, again, public. You could just grab this script, create an exe file, and then you're going to get these two particular headers back, which I think now it's actually 4, because I am now seeing like it's XMS device credential 1 and refresh token credential 1 as well. That keeps changing. It doesn't matter as long as this functions. This has really low detection rate. They don't care because, I don't know. So you exchange this for, once you have that, you can typically exchange this for a longer-lived ES2ES auth persistent token and ES2ES auth token here. This is just the client ID for Office Home. So if you grab, once you send this from the target device and you capture these cookies, you could just simply copy paste into your browser and then go to login to microsoft.online.com, and you will be logged in as the target user without the device, without being on the device. So you could do that from an attacker machine. All right, so we're going to discuss a few lateral movement techniques as well. So this is where we were expanding scope as that particular user, and I'm pretty sure that would help you achieve few of the objectives beyond just credential dumping. So because if you could go from consumer apps to enterprise apps to your cloud apps, and then I'm pretty sure you could go more deep into stuff. But if you want to move laterally as well, you want to expand your user scope as well. So using that user's permission, you would want to deploy malicious apps or launch spear phishing campaigns. That's just one of the ways. Or we want to basically hit for enumerate misconfigurations within the cloud environment as well. So in this scenario, it's like Azure-based stuff, right? So you want to elevate to contributor owner role within resource groups which the user already owns. Depending on what kind of privilege identity management is already enabled, this may or may not succeed. Obviously, this lack of MFA is the easiest target. So, but that can be bypassed if you already have the tokens, because now you're directly interacting with the API and you don't care about MFA. But if there's lack of MFA, that's amazing, because now you can actually use Portal to do stuff. And this is very interesting, which we are seeing more and more, is cross-tenant sync, which is basically setting up B2B collaboration. An attacker, once they gain a foothold into your network, would probably try to set up a B2B sync. So if you want to trust a child directory, for example, your company acquires some other small company and they want to be onboarded to your directory, they won't be onboarded like one-to-one. It's just that they establish a trust relationship between their domain and yours, and they have a lot more expanded privileges than just guest users. They're not just guest users, they're like members, more or less, within your directory. So an example kill chain would be basically, as a regular user, you generate an access token for Portal, you list Azure resources or locate an admin considered application for elevated permission. And then one of the typical TTP for attackers these days, like you add a new credential to that particular application, which may or may not be detected, but it's worth trying. And then use that client credential grant flow to obtain access control, access token for that targeted tenant by doing a cross-collab B2B. And then you maintain persistence to the data based on the application's permissions. So this is, you're just attacking Azure applications now, and now interacting with whatever permissions it has, like emails or files or directory level permissions as that particular uses. So we are almost towards the end. There are some defenses which we can discuss based on this. So the most obvious ones is like, so these are in addition to what your EDR, XDR already does. Some of these can be automated, but as defenders, you want to enumerate all the memory dump types. Like, for example, there are like a bunch of subtypes which you could use for process dumping, right? Like the one we showed that was successful. And then use that for all popular tools, because every tool has a different signature. Every the method of dumping is different. So you'll have to look at like what the API calls are on an OS level, and then see, okay, why is this process doing that? Is that even required? And then it's not actually foolproof, obviously, right? But you can definitely scope any non-development machines into this rule to see if you might be able to thwart an attacker or something. And then similar things for like accessing, monitoring the file system as well. So for example, we showed level DB files and stuff like that. Like nobody should be accessing that besides the browser, right? Or yeah, that's about it. Or the application binary which created that folder, right? There are like a bunch of attack surface reduction rules which detect, block, and block suspicious behavior from certain processes. So those should always be enabled. Windows Defender has a bunch of them, but I'm pretty sure every EDR does that. Detect creation of external identities which are linked to the current tenant. So you should be auditing that every once in a while to see like who shares cross-tenant trust relationship in your tenant in Entra ID. And like what has recently changed in that environment. And then enable conditional access for access tokens. So it basically helps us detect token theft using the attacks which we mentioned. So it's called token binding as well. So because once I lift off the token of your device and start using it from a different geolocation or from a different time zone or stuff like that, this can be easily detected. So Entra ID, I think, now provides ways to enable that. And then, for Windows 10 and newer devices, which I'm pretty sure all enterprise devices usually are, they have policies to ensure that only bound sessions using the PRTs are able to authenticate to Entra ID. So token binding is very important because, as I said, like once you lift it off, you're off the races, right? It could be valid for 1 hour, and then if you have RT refresh tokens, potentially more. All right, so yeah, that's pretty much it. Thank you so much. I went very fast.
Thank you very much. Any questions?
Is Microsoft going to be doing anything to help us detect this stuff on the Azure side?
So yes and no. So because you have to tailor your defenses to your own environment. They do have detections, but like you have to enable them, right? And then I believe like you should be writing custom detections for your particular environment, right? Because they don't know they have a bunch of customers, like they want hundreds of use cases, right?
So I agree that on the EDR side, locally on the machine, we should have detections. I'm talking about more on the Azure side for token reuse or token brute forcing, et cetera.
Yeah, so as I said, like there are like always new things coming up. Like I think this is kind of new. It was in preview, like token theft, but like so you'll have to configure like what it looks like. Like, do you want an employee logging in from North Korea at 2 a.m. in your time zone? Like potentially that's a problem, right? So you decide that. But yes, it is available. Stuff like that is available.
More questions? No. So we are done on this track for today. Thank you very much again, Priyank.
Thank you.
And have a nice evening.